So let's work a little bit about 4-7. Inverse trigonometric functions. Inverse functions. Do you remember any of the basics about inverse functions? Like I just taught inverses in Algebra 2. Just a couple of lessons ago. Do you remember how to find an inverse function? Okay, yeah. So when we're talking inverse function, an inverse function is switching the x and y value. Or in other words, think it's switching the input and the output. What was the input becomes the output. What was the output becomes the input. Okay, so the idea of an inverse is it switches the x and y. Now, we are specifically talking about the three main trig functions, sine, cosine, tangent, and their inverses. So, first of all, notice right up there, it says this is y equals, I'll read this as sine inverse of x. Okay, this is a button on your calculator, yes? This is the button when we were graphing reciprocals that I said don't touch. Because here is the actual purpose of it, okay? It's the inverse button. It's not the reciprocal, it's the inverse. Total different thing. Inverse and reciprocal are not the same thing. So, y equals sine inverse x. This is kind of my preferred form. However, the book, AP Calc Test, various places, also use arc sine x. Okay, so you need to be aware that that is equivalent. I believe, if I recall off the top of my head, our book uses both. So it's not, I know AP Calc definitely goes both ways. And I believe our book does some of both. Yes. Okay, so you could see them say, you know, what is sine inverse x of this? They could also say, what is arc sine of this? Okay, same thing. So just be aware that those are equivalent. Now, as we talk about sine, we're going to talk about domain and range. Okay, and the domain of the inverse sine function. So when we talk domain, that is your input, right? Your input of the inverse sine function is negative 1 to 1. That means you can find sine inverse of anything between negative 1 to 1. If it is something that is outside that set of numbers, you can't find arc sine of that. Okay? And so, beware there. So notice it says all values inside the inverse sine function will be between negative 1 and 1. And we haven't looked at graphs of sine yet, but this is equivalent to the normal range, the range of a normal sine function. Okay? Now, range. Range of the inverse sine function is negative pi over 2 to pi over 2. So all of your output answers will be between negative pi over 2 and positive pi over 2 when we're talking about inverse sine. Now, we say negative pi over 2 to positive pi over 2 because we're talking radians there. And we will usually be talking radians. However, if we said degrees, that would be equivalent to what numbers? What is negative pi over 2 and positive pi over 2? So 90 and negative 90. Okay, so all of our outputs for the inverse sine function will fall between negative pi over 2 and positive pi over 2. So negative 90 and positive 90. And in case we've forgotten, domain is x, range is y. Correct? Now, normally you're used to me asking, say, what is the sine of pi over 4, correct? With sine inverse, the idea is I will say sine inverse of what? I don't want to say this. It'll be like sine inverse of what equals square root of 2 over 2. So it's going to be reversed where I'll be more giving you the answer on the chart and you have to find the angle. Okay? And that leads into this right here. The answer to the inverse sine function is an angle. Okay? And if you think about it, that should make sense because it's an inverse. And what's the inverse do? It switches the input and output. Now, before we go on, we're going to flip to the back side of the notes for a moment. There's something I need to show you. If we flip to the back side of the notes, there are 3 half circles, yes? We're only going to focus on sine inverse for the moment. But what this sine inverse is doing, notice this half circle goes from negative pi over 2 to positive pi over 2. So what is this graph showing? This is showing you the possible range values. Okay? So when you give me an answer, it has to be somewhere on this half circle. You won't be able to give me a sine inverse answer that's over here in quadrants 2 or 3. You'll have to be in quadrant 1 or quadrant 4. However, notice, how is quadrant 4 labeled? Is that the typical labelings on quadrant 4? Now, quadrant 4, we would typically have the things leading up to 2 pi, but this is if you were at 0 and you were counting down. And so if you're giving me an answer in quadrant 4, you have to use one of these angles, not what it would be equivalent to like on the normal unit circle. So like, for instance, negative pi over 6, that's equivalent to 11 pi over 6. But if you tell me 11 pi over 6 for an inverse sine answer, I'm going to count it wrong because that's not in the appropriate range. Okay? And we already talked about this is the equivalence of going negative 90 degrees to positive 90 degrees. Okay, you got that half circle in your head? I'll be honest, that's what it comes back to for me is I have to visualize that half circle. Let's try a couple of these. You have your chart in front of you? Because your chart's still going to be helpful. Example 1. First of all, it says find the exact value of each of the following without a calculator. Because is your calculator going to give you an exact value? Not necessarily. Okay. If it's something where it gives you a big old decimal, that's not helpful. So exact value is not using the calculator. That's giving me an exact non-rounded answer. So something that involves a square root depending on the situation, or involves pi, or whatever the case is. Okay, a sine inverse of 1/2. I want to know what sine inverse of 1/2 is. Any thoughts based on what I've already said? It's on your chart, technically. Think about sine and think about 1/2. What do you know? Okay. If you look on your chart, that top row, sine of 30 degrees is equal to 1/2. Now let's talk radians though. Instead of 30, you're going to tell me pi over 6, right? Equivalence, I get it. Okay. So now, does this make sense? Because it has to fit in the proper domain and range. First of all, because this problem becomes not doable if they're not appropriate domain and range values. Is 1/2 an appropriate domain value according to the top of my page? Yes, because my domain was -1 to 1. I can do sine inverse of anything between -1 and 1. So that works, yes? What did you guys say you thought the answer was? Pi over 6. Is that an appropriate range value? My range value is supposed to be something between negative pi over 2 and positive pi over 2, right? So if you drop off the pi's kind of between -1/2 and positive 1/2. Is 1/6 there? Yeah. And we know this is just a positive 1/2, right? Out of quadrants 3 and 4, where is sine positive? Sine is positive in quadrant 1, yes? Excuse me, I said the wrong thing there, didn't I? Out of quadrants 1 and 4. Better question? Out of quadrants 1 and 4, where is sign positive? It's positive in sign 1. Quadrant 4, what do we know about sign? It's negative. So we know we have to be talking about quadrant 1. Okay, that's the basic intro there. Got the idea? Okay, let's try B. Sine inverse of negative square root of 3 over 2. What'd you say? I technically have to say no. Meaning, you're on the right track, however, you put that answer down, I have to count it wrong. His answer was 5 pi over 3. If you look, is 5 pi over 3 in my range? My range is, I can give an answer anywhere between negative pi over 2 and positive pi over 2. So numerically, I know you're looking at your chart and you're like, it's on the chart in that spot though. So what I'm trying to say is, what is another name for 5 pi over 3? Negative pi over 3 is what I'm looking for. Do you see where I'm going with that? If you flip back on the back of your notes, okay, it's a pi over 3 in this quadrant. And I agree, this is the location of 5 pi over 3. But it's a big technicality, and 5 pi over 3 is wrong. That's not in the acceptable range. But the equivalent name to 5 pi over 3 is negative pi over 3. Okay? Now, did you check domain and range to make sure this made sense? First of all, I'm guessing you probably went sine square root of 3 over 2, yes? Where does sine equal square root of 3 over 2? And that happens at pi over 3, right? 60 degrees. Now, so I agree with the pi over 3, but because this is negative, we need to be down in quadrant 4. What's the equivalent angle in quadrant 4 to pi over 3? And that is the negative pi over 3. Okay? And that's obviously in my acceptable range. Negative square root of 3 over 2, was that my acceptable domain? I should have checked that first. But it was, because square root of 3 is 1.7 divided by 2. That puts me under 1. So all is good there. Okay? And if you need a visual, the idea would be, I have to be on this side of the circle somewhere, right? So if normally it's up here at pi over 3, the equivalence is down here at negative pi over 3. Okay. Well, if I don't stop there, I'm getting caught in the middle of a problem. So, we will revisit this Monday. Since there's 5 people missing out of your class today, you'll probably get a good solid review of what we've just gone over, because when we move on to C, it's not going to make sense if I just start talking about C. So we'll review, pick up Monday. That homework that I have listed there, I wouldn't worry about it yet because we haven't really done a whole lot with it yet. So you can enjoy the weekend. We'll come back and talk about it on Monday. If you didn't get Khan Academy done, make sure you get that done.